Alright, in this video, we're going to take the stoichiometry concept and go a little bit further, and we're going to do something called limiting reactant. It's something you should be familiar with if you've cooked before. And we look here, and I've got the recipe for my favorite kind of pizza, maybe it's yours, and that is Chicago-style deep dish pizza. It's part of the reason I moved to Chicago, so I can just eat that. But as you're cooking the pizza, you will run out of an ingredient. And that first ingredient you run out of, that will determine how much pizza you can in fact make. For example, let's say that we run out of, if we look here for the filling, we've got all these amazing ingredients, but let's say we run out of basil. We just didn't get enough basil. We weren't thinking about it. So we're out of basil. Well, that basil, the lack of basil will mean that we can make no more pizzas. So let's say we could only make one pizza because we ran out of basil, so we only had 1 teaspoon of basil. And so the thing that the ingredient that we run out of first, in chemistry terms, we actually call that, and I'm putting it's at the top of the picture here. It is called the limiting reactant. You can see here, and so the other ingredients, however, are not known as limiting reactant. They're called the excess reactant. So here you can see the excess reactant. So we got rid of the basil, and now we're left with all of these other ingredients. So these are the excess reactants. Now, another way to think about it is maybe in terms of this car, of making a car. So if we have some reaction, where a car reacts with 4 tires to make, or a car body reacts with 4 tires to make a car, we could see in this situation, here we have 8 cars and 48 tires. We actually will run out of the car bodies first, and so that limits how much we can make. We can only make 8 cars. So what we would say is that the car bodies are the limiting reactant, and the tires are the excess reactant because there will be 16 tires left over. And then what it looks like in a chemistry problem is if you're given finite amounts. Actually, I don't know if you guys like the red one or the finger for these videos. We'll just do the finger. So here you can see we have the zinc and the 2HCl. They give us amounts of each. So 1.21 moles of zinc, 2.65 moles of HCl. And so we have to figure out which one will run out first. And the way we do that is a two-step process. We first use the amounts given, here and here, to determine how much of the product each one will make. So 1.21 moles of zinc, if we follow this as balanced, if we follow the mole-to-mole ratio, we can solve and see that we get 1.21 moles of zinc chloride. Using the HCl, we see that we only get 1.33 moles of zinc chloride. Well, if we go to step 2, the reactant that made the least product is the limiting reactant. And you can see that 1.21 is less than 1.33, and 1.21 was the result of the zinc. So the zinc is the limiting reactant, the HCl is in excess. And so then we use the zinc, and from that point on, we use only the zinc in the stoichiometry part of the problem. And we've already know how many moles of zinc chloride we make with our limiting reactant, and we find out how much zinc is produced. Now, there's going to be leftover HCl. How much? Well, if we start with 2.65 moles of HCl, and using the molar mass of HCl, we can see that that is 96.7 grams. We can then go backwards knowing that we use 1.21 moles of zinc to find out how much HCl we actually use. So I use the mole ratio between HCl and zinc, and then the molar mass of HCl, and I find that I used 88.3 grams of HCl. The difference between those two, and there is a difference between the two, 96.7 minus 88.3 is 8.4, and that is the amount of excess HCl left. You can think of this step 1 and step 2 in this way. How many cars can I make from 8 car bodies? Well, I can make 8. How many cars could I make from 48 tires? Well, 4 tires for a car, 4 goes into 28, 12 times. So, which one's the limiting reactant, 8 or 12? Well, this makes 8 cars, this makes 12 cars, so this is our limiting reactant. And that's exactly what we do in step 1 and then in step 2. Figure out which reactant makes the fewest number of products. Well, let's do it in an actual chemistry problem now. Okay? So let's first write the balanced reaction for this. So this is N2 plus H2. Both of these are diatomic, and it forms ammonia, which is NH3. And to balance that, I've got 2 nitrogens here. I've got 2 nitrogens here, so I want to put a 2 there. And then that gives me 6 hydrogens, so I put a 3 there. And we now have a balanced reaction, so I put a box around that. And so let's go down now and let's use both our reactants. So we'll start with nitrogen, so 28 grams of N2. And I know that 28 grams is the molar mass of N2, is 1 mole. And the mole ratio between N2 and NH3 is 1 to 2. So 1 mole of N2 makes 2 moles of NH3. I do that, and that gives me 2 moles of NH3. And then if we use our hydrogen, 25 grams of H2, 1 mole of H2 is 2 grams of H2. And then the molar mass between NH3 and H2 is 3 moles H2 to 2 moles of NH3, and I solve that, and that actually gives me 8.33 moles of NH3. And so now we're ready to choose our limiting reactant. We can see we used both of the reactants and found how much product could be made. This is less product. So our limiting reactant is N2. So the question says how many grams of ammonia can be produced? Well, the amount that N2 makes, right? So we have 2 choices. We could either go with the 2 moles or the 8.33 moles. This is the amount of NH3 that can be made, because we will run out of N2. N2 is our limiting reactant. So if we take this number and convert it to grams of NH3, we'll know how many grams of ammonia we make. So 2 moles of NH3, and then I just need to get to grams. So 1 mole of NH3 is 17 grams of NH3, and so we get 34 grams of NH3 is produced. Okay, so that's the first part. And then it says how many grams of excess reactant remain. So we're going to make 2 moles of NH3. So let's use that and figure out how much H2 we would need. So I can start 2 moles of NH3. And what's the mole ratio between NH3 and H2? NH3 and H2, it's 2 to 3. So 2 mole NH3, 3 mole H2. And so moles of NH3 cancel out, and we're left with 3 moles of H2 are used up. So this is used, right? Because when 2 moles of NH3 react, when 2 moles of NH3 are made, 3 moles of H2 are used, right? And when that 2 moles of NH3 is made, it uses all the nitrogen, but it only uses 3 moles of hydrogen. And we found earlier, and we know from this here, that we have actually 12.5 moles of hydrogen. 25 grams of hydrogen divided by 2 is 12.5. So it says how many grams of excess remain. First of all, we can do the mole. 12.5 minus 3 equals equals what is that? 9.5. So 9.5 moles. And then the molar mass of H is 2, so multiply that by 2, and so you end up with a molar total of excess left of 19 grams of H2. It's got a little messy here, trying to keep it all on the same page, but that is our first problem, and now you have an idea. So practice a couple in the book or on your SSS, and bring any questions you have to class. But that's it. Just follow the steps, determine the limiting reactant, and then use that limiting reactant to calculate the amount of product formed.